Hey everyone, welcome to our deep dive today, all about mesenchymal stem cells.
MSCs.
Yeah, you got it,
Yeah.
MSCDs. And you're here because you're interested in going beyond just like the hype and really understanding the science behind these cells.
Absolutely. And it's a really exciting time to be talking about this, especially with the recent FDA approval of RYONCil.
Yeah.
That's the first MSC therapy to be approved here in the US.
It's a big deal for sure, and we're definitely going to be digging into all of that.
Yeah.
But before we get ahead of ourselves, can you just give us like a little bit of context? What are MSCs and why are they such a big deal in medicine these days?
Yeah. So MSCs are kind of like the body's own little repair crews.
Okay.
They're these multipotent stromal cells, and we find them in a bunch of different tissues, like bone marrow or adipose tissue, even in the umbilical cord blood.
Okay.
And what makes them so interesting is their ability to kind of modulate the immune system and promote tissue repair. And some people think they can even differentiate into other cell types like bone or cartilage.
So they have like the potential to address all kinds of conditions then.
Yeah, a lot of different things.
That's amazing.
Yeah.
So let's talk about Ryan and Cell then,
Okay.
and the company behind it, Mesoblast.
Right.
Now, from what I understand, they're really focused on these off-the-shelf allogeneic cell therapies,
Hmm.
which means that they use donor cells instead of having to harvest them directly from a patient, right?
That's right. Okay.
Their whole goal is to create these cell therapies that are just readily available,
Yeah.
that can be used for a whole slew of different diseases.
Mhm.
And RYONCIL is really their first FDA-approved therapy, and that one is specifically for treating children with something called sr-agvhd.
Yeah, that's a mouthful.
Yeah.
Can you break that down for us a little bit? What exactly is that?
Sure. So sr-agvhd, it stands for steroid refractory acute graft versus host disease.
Okay.
It's basically a very serious complication that can happen after a stem cell transplant.
Oh, wow.
And essentially what happens is that the donor's immune cells start to attack the recipient's body.
And it causes all this inflammation and damage to their organs.
It sounds really serious.
It is. It's life-threatening, and especially for children who don't respond to steroids, the outlook is pretty grim. So RYONCIL really offers a new hope for these kids.
Yeah, it sounds like it. And their phase 3 trial results were pretty impressive, weren't they?
Yeah, they were really interesting. The trial showed that 70% of the children who were treated with RYONCIL had a response by day 28.
Wow.
Yeah, and that's really significant, especially since most of those kids had really severe cases of sr-agvhd. Clinical trials, they're complicated, and we always want to be careful about over-interpreting the data,
Sure.
but this is definitely a promising step forward.
Absolutely. Now, before we get too deep into the specifics of RYONCIL, I think it is worth pointing out that, MSC-based therapies in general have faced some pretty big challenges over the years, right?
Oh, yeah, for sure.
Can you talk a little bit about some of those hurdles that researchers have had to overcome?
Yeah, so I think one of the biggest challenges with MSCs is just how different they are. We call it heterogeneity
Okay.
because they can be derived from different tissues and different donors. Their properties can vary a lot,
Yeah, that makes sense.
and that makes it really hard to standardize these therapies and to know for sure how they'll work in different people.
Yeah, you can't just assume that all MSCs are going to be the same.
Exactly.
That's not a one-size-fits-all kind of thing.
Yeah, and it's like comparing apples to oranges.
Right.
It's just not going to work.
Okay, so that's one challenge. But what about like actually figuring out how effective a batch of MSCs is? I mean, how do you measure something like that?
That is a great question, and that's another big challenge.
Yeah.
Developing what we call potency assays.
Yeah.
We need really accurate ways to measure the potential of these cells.
Okay.
It's not enough to just see how they grow in a dish in the lab.
Right.
We need to know how they're going to actually function in the body.
Right. And how do you measure something as complex as that?
Well, that's the million-dollar question, isn't it?
Yeah, it seems like it.
Researchers are working really hard to try and develop these assays that go beyond just measuring how well the cells grow, or if they differentiate. They're looking at things like what kind of biomolecules are they secreting, how well are they modulating the immune response,
Okay.
even are they releasing these little packages of cellular material called extracellular vesicles
Oh, wow.
that can influence the behavior of other cells.
So there are a lot of moving parts.
Yeah, there's a lot going on.
And it sounds like there's still a lot of work to be done in terms of standardizing these therapies and, really nailing down how to measure their effectiveness.
Absolutely.
But Mesoblast, it seems like they've figured some of this out with RYONCIL.
Yeah.
So what's their secret?
Well, I wouldn't say it's a secret as much as it is just really rigorous science. They're using innovative technology And they have a really deep understanding of the specific MSC population that they are working with. So one key, I think, is their manufacturing process.
Yep.
They've really developed a very specific system that lets them produce huge quantities of MSCs while maintaining their quality and making sure that they're consistent.
So they figured out how to basically scale up production without losing the quality.
Yeah, exactly. That's no easy feat.
No, it's not.
And they've done that by using a combination of what we call 2D and 3D bioreactor technology.
Interesting.
And this makes sure that the cells are grown in a very controlled environment
Okay.
that kind of mimics what's going on inside the body,
Okay.
which helps preserve all those therapeutic properties that we want.
Now, what about that potency assay issue? Like, how did they prove to the FDA that RYONCIL was going to be effective for sr-agvhd?
Yeah, so I think that's where their deep dive into these biomolecules that RYONCIL secretes comes into play. They've pinpointed the key factors that contribute to its ability to modulate the immune system, including its ability to kind of turn down the production of those pro-inflammatory cytokines and turn up the production of anti-inflammatory cytokines. So they're really fine-tuning the immune response.
So they're not just like throwing cells at the problem.
I don't know.
They're being very specific about which cells they're using.
They're being very picky.
And how they're actually making sure that they have the effects that they want them to have.
Absolutely. It's all very carefully characterized.
That's fascinating. Now, this FDA approval, I mean, it's got to have bigger implications, right?
Oh, for sure.
Does this open the door for more MSC-based therapies for other conditions, too?
Oh, absolutely. The approval of RYONCIL, it's a huge moment for the field of regenerative medicine.
Yeah.
It really validates the potential of MSCs
Okay.
and paves the way for a lot more research and development in this whole area.
That's really exciting. So we've talked about mesoblast, we've talked about RYONCIL, and some of the challenges of working with MSCs. Now, I want to kind of shift gears a little bit and dive deeper into the potential of these cells. I mean, what other areas of medicine could be impacted by MSCs?
I mean, the potential is huge. It's really vast.
Yeah.
And we're really just scratching the surface, I think.
Okay.
But maybe we can start by talking about some areas where MSCs are already showing some promise.
Yeah, that sounds great.
So one area that's getting a lot of people really excited is orthopedics. MSCs, they could totally revolutionize the way that we treat things like osteoarthritis or cartilage injuries or even bone fractures.
Yeah, I could see how that would work. Like you said before, they can differentiate into bone cells or cartilage cells, so they could theoretically help repair that damaged tissue.
Exactly. And it's not just about replacing the damaged cells.
Okay.
They also secrete all these growth factors and cytokines that stimulate the body's own repair mechanisms. So it's almost like giving the body's natural healing process this extra boost.
So they're like coordinating the healing.
Yeah, orchestrating the whole symphony.
That's pretty amazing. What about other areas?
Well, another really promising area is cardiovascular disease. MSCs have shown that they might be able to repair heart tissue after a heart attack.
Wow.
And that could improve heart function and maybe even help grow new blood vessels.
They could potentially help regenerate damaged hearts.
Yeah, that's the idea.
Yeah.
And again, it's not just about replacing the damaged cells.
Okay.
They also have these powerful anti-inflammatory effects,
Right.
which can reduce the long-term damage from things like heart attacks.
Yeah, because inflammation is a big part of a lot of chronic diseases.
Right.
So if you can kind of control that, you could have benefits for all kinds of things.
Absolutely. And speaking of inflammation, MSCs are also being looked at for their potential in treating autoimmune and inflammatory disorders. Things like Crohn's disease, rheumatoid arthritis, and lupus.
Yeah, because of those immunomodulatory properties that we talked about.
Exactly.
So they could potentially help to rebalance the immune system and stop it from attacking the body's own tissues.
That's the hope. And then there's even research looking at their potential in treating neurological conditions.
Really?
Yeah, like stroke, spinal cord injury, even MS.
Wow, so they can help with brain and nerve repair. How does that even work?
It's really interesting, actually. So first, they can help reduce inflammation in the brain and spinal cord,
Okay.
which is really important for limiting the damage after an injury.
Yeah, makes sense.
And then they also secrete what we call neurotrophic factors. These are special proteins that actually support the survival and growth of nerve cells.
Okay.
And there's even some evidence that MSCs might be able to differentiate into neuron-like cells in certain situations.
So they could promote nerve regeneration?
Possibly, yeah.
That's incredible.
It's pretty remarkable. And honestly, the potential applications don't stop there. Researchers are looking at using MSCs in wound healing, diabetes, lung disease, even certain types of cancer.
I mean, is there anything these cells can't do?
Well, let's not get ahead of ourselves. There's still a ton of research that needs to be done.
Right.
And not all of these potential applications are going to pan out.
Yeah, I get that.
But the fact that there are so many possibilities, that's what makes this field so exciting.
I totally agree. But let's take a step back for a minute.
Yeah.
We've talked about all these potential uses, but can you break down some of the key mechanisms of how MSCs actually work? Like, how do they have these therapeutic effects?
Yeah, good question. So one of the key mechanisms is something called paracrine signaling.
Okay.
Basically, MSCs are like little factories,
Okay.
pumping out all these beneficial molecules like growth factors, cytokines, and chemokines.
Okay.
And those molecules act on the neighboring cells. They stimulate tissue repair, they reduce inflammation, and they help to modulate that immune response.
So it's not just about replacing the damaged cells.
Right.
It's also about sending out signals that kind of kickstart all these other healing processes.
Exactly. And in addition to that paracrine signaling, they can also make direct contact with other cells, which lets them influence how those cells behave in a very precise way.
So they're like master communicators,
Yeah.
using all these different ways to get their message across.
I like that. Yeah, that's a great analogy.
And then there's those extracellular vesicles that we talked about earlier.
All right, right.
Those little packages of cellular material.
Yeah, those are like little envelopes that are packed with biological messages,
Okay.
and they can travel all over the body, delivering their cargo to distant cells.
Wow.
We're really just starting to understand what these vesicles can do,
Yeah.
but it's clear that they play a big role in how MSCs work.
So it's not just the cells themselves that are doing the work. It's also these messages that they're sending out.
Exactly. And the more we learn about all these different mechanisms, the better we'll be able to use the full potential of MSCs.
Yeah, that makes sense. I have to admit, though, I'm still a little skeptical. This all sounds almost too good to be true. Are there any downsides to MSC-based therapies? Are there any risks?
That's a really important question, and I think it's always good to be cautious when we're talking about new therapies.
Yeah.
Like any medical treatment, MSCs do have potential risks.
Okay, can you give us some examples?
Yeah, so one thing is always the possibility of an unwanted immune response.
Okay.
Even though MSCs are generally considered to be immune privileged, which means that they don't usually trigger an immune reaction,
Okay.
there's always a chance that the recipient's immune system could reject those donor cells.
So just like with an organ transplant, you have to make sure that there's a good match.
Yeah, exactly. Another potential risk is tumor formation. Because MSCs can self-renew and differentiate, there's this theoretical risk that they could grow uncontrollably and form a tumor. Okay.
But I want to emphasize that that risk appears to be very low based on all the data we have so far.
So it's a possibility, but not necessarily a major concern.
Right.
Are there any other potential downsides?
Well, one challenge is definitely the cost.
Okay.
Producing MSCs on a large scale is still pretty expensive,
Yeah.
which makes these treatments hard to get for a lot of people.
Yeah, that's a problem.
But as the research moves forward and the manufacturing techniques get better, we expect those costs to go down.
So it's a matter of time.
Hopefully.
Yeah.
Yeah. And another challenge, I think, is the whole regulatory landscape.
Okay.
Getting new therapies approved, it's really complicated, and it takes a long time.
Yeah.
Sometimes it can take years or even decades to get a new treatment to market.
And I imagine there are a lot of hoops to jump through to make sure that it's safe and that it actually works.
Oh, absolutely.
Right.
The regulatory agencies have to be very thorough before they let something new be available to the public.
Yeah, of course. And that process can sometimes feel really slow and frustrating.
Sure.
But ultimately, it's there to protect people and make sure that everyone is getting safe and effective treatments.
So even though there are challenges and risks, it sounds like the potential benefits are so big that it's definitely worth it to keep doing this research.
I think so, too. I'm really optimistic. I think
Yeah.
it's really promising.
Well, we've covered a lot today, and I feel like I have a much better understanding of MSCs now.
Good. I'm glad.
But before we wrap up, I'm curious to hear your thoughts on the future of this field. What are some of the most exciting developments that we can look forward to in the coming years?
I think one thing that's really exciting is this idea of personalized MSC therapies.
Okay.
You know, we're learning that not all MSCs are created equal.
Right.
Their properties can be different depending on the donor, the tissue source, and even the patient's own genes.
Oh, wow.
So the idea is to use all of that information to choose the most effective MSCs for each individual person.
So it's about personalizing the treatment.
Yeah.
Tailoring it to each person's specific needs.
That's really fascinating. How would that actually work in practice?
Well, there are a few ways to approach it. One way is to use genetic testing to figure out who's more likely to respond well to MSC therapy,
Okay.
or to find MSCs that are more compatible with the patient's immune system. Another way is to actually modify the MSCs themselves,
Oh, wow.
either by editing their genes or by exposing them to specific growth factors or cytokines.
Okay.
And that can enhance their therapeutic properties.
So it's about tweaking the therapy to make it as effective as possible for each individual.
Yeah, that's the idea.
That's a really powerful concept. Are there any other promising areas of research that you're excited about?
Yeah, definitely. Another area that's gaining a lot of traction is using MSCs in combination with other therapies.
Okay.
For example, researchers are combining them with biomaterials
Yeah.
to make scaffolds that support tissue regeneration,
Okay.
or they're using gene editing to enhance the MSCs or make them more resilient in the body.
So it's like a multi-pronged approach.
Yeah, exactly.
And then there's the development of those off-the-shelf allogeneic MSC therapies that we talked about with RYONCil.
Right.
I mean, if we could create banks of MSCs that are safe and effective and readily available, that would really be a game changer.
Oh, absolutely. I think it would make these treatments much more accessible and affordable.
Yeah, definitely. So for our listeners out there who are interested in learning more about MSCs, what would you recommend? Where should they go from here?
Yeah, that's a great question. First, I would say don't be afraid to dive into the research yourself.
Yeah.
There are tons of resources online and in libraries, and new studies are coming out all the time.
Okay.
Second, stay curious. This field is constantly changing, so it's important to keep up with the latest developments.
Yeah, keep learning.
Exactly. And third, don't be afraid to ask questions. Reach out to experts. Go to conferences. Get involved in discussions.
And I would add to that, it's important to be a little bit skeptical.
Yeah, for sure.
You know, this is a really new and promising field, and there's a lot of hype out there, so be careful.
Look at the evidence carefully, and don't just believe everything you read.
Absolutely. Critical thinking is so important, especially when we're talking about something as complex and potentially groundbreaking as this.
Well, I think we've covered a lot of ground today, and I'm feeling pretty optimistic about the future of MSCs.
Me too.
It's clear that they have the potential to change the way we treat a whole range of diseases.
Absolutely. I think we're on the verge of a new era in medicine,
Yeah.
and MSCs are going to play a big part in that. It's a really exciting time to be involved in this research, and I can't wait to see what the future holds.
And to our listeners, thank you for joining us on this deep dive into the world of mesenchymal stem cells.
Thanks for listening.
We hope you learned something new and that you'll continue to explore this fascinating field. Until next time, stay curious, stay engaged, and keep exploring the frontiers of